this is Honey Pandey here. Today I'm going to be presenting a video on my presentation which is based on cryptography in embedded systems. So let's get into the presentation. All right. So as I said before, my topic for today is cryptography in embedded systems. So this is a few topics that I will be covering today. Introduction, what do you mean by cryptography, the classification of cryptography, the algorithms used, a few comparisons, advantages and drawbacks, and in the end a conclusion. Now, embedded systems today provide reliability, flexible functionalities, and have been implemented in real-time systems. Over the last few decades, embedded systems have found their applications in areas of managing very extensive data. And since they are handling a lot of data, it makes security a very important factor of embedded systems. And for that, we have to implement data encryption and decryption, which is done by cryptographic algorithms. Moving on, what is cryptography? Now, in our case, let's look at the image. So Alice is the sender and Bob is the receiver. And Eve is the middle person who is listening to the channel. Now, if Alice is to send the message without any encryption code, then Eve would be able to decode it, tamper it, or do anything with the message and change the origin of the message. And Bob will not be able to get the information that he's supposed to get. But Alice, being a smart person, encrypts the data and then transfers it over the channel. So what Eve hears is a ciphertext, which will make no sense. And then Bob gets the data, he decrypts it, and then he gets the information that he's supposed to. And Alice tells Bob what is the code which he can use to decrypt the data. This is nothing but basic cryptography. Now, what is cryptography involving? It involves the study of mathematical techniques which helps a user achieve the following objectives. The first and foremost being confidentiality, which is the access of information is only done by authorized users. The second being integrity, where only an authorized user is able to modify or make changes to the data that is given. Authentication is just assuring that the origin of message is the same, that it's not being tampered with in the middle. And the last one being non-repudiation, which prevents the data to be denied by either the sender or the user, or maybe both. Now, cryptography can be classified further into two kinds: symmetric key ciphers and public key ciphers. Now, symmetric key ciphers, step one being we select a key which is used for encryption. So once the sender selects the key, the sender will give the key to the receiver. Now, this is done before, or it's a separate thing that happens. And then the sender will use the key that he sent to the receiver for encrypting the data. And once they encrypt the data, they pass on the ciphertext over the channel, and then the receiver receives the ciphertext and uses the key which was given by the sender to decrypt the ciphertext and get the information. Moving further, symmetric key ciphers are also known as private key algorithms and are mainly classified into two varieties. The first one being block ciphers, and the second one being stream ciphers. So block ciphers have messages broken into blocks, and then they are encrypted, a block after block. Stream ciphers, on the other hand, operate only on a single bit of text at a time, which means that their block is of size 1 bit. Now, ciphers are further divided into DES, 3DES, and AES, where DES stands for Data Encryption Standard and AES stands for Advanced Encryption Standard. Nowadays, Advanced Encryption Standard is being used, but DES is still a renowned algorithm, and we will look further into it. So, this is the basic flow diagram of a data encryption standard. Let's get into it. So, we handle 64-bit plain text, which is to be encrypted into a 64-bit ciphertext. Now, initially, initial permutation takes place, which is nothing but rearranging of the bit order so that it's a first stage of ensuring an encryption. And then it undergoes 16 rounds, or basically 16 blocks. This is a 16-block encryption using a key which is generated by a round key generator, which is nothing but you get a cipher text of 56 bits, cipher key of 56 bits, and it's converted into 48 bits of keys each. So we're not going to look into how the key is generated because that is another lengthier method. So we're just going to see how the basic and data encryption is done. So now at every round, you have your 64-bit text encrypted with so this 64 plain bit text is divided into 32 bits as seen. Now this is an expansion of the rounds that takes place. So initially the input bit that you get is of 32 bits, and then the 32 bits get expanded to 48 bits, and we do the XOR function with the incoming key. So here you have the 48 bits of data and you XOR it with the 48 bits of key. And that 48 bits goes into S boxes. Now S boxes is nothing but confusion creation. So it's nothing but confusion boxes. So P boxes are known as diffusion boxes and S boxes are known as confusion boxes. So what these are, they are 8-bit long blocks, and they convert 6 bits. So 48 bits are divided into 6 bits each. So it's 8 times 6. Now those 6 bits get converted into 4 bits. So S box converts the 6 incoming bits into 4 outgoing bits, sorry, to get a 32-bit data. And that is given as an input to the second block. So this way we do an encryption which is 16 blocks long. So you have like one after the other, you go on, and then in the end you get the final permutation. You do the final scrambling to get your ciphertext. Moving on to public key ciphers. Now public key cipher is a little different from symmetric key. Here there is two steps. The first is the receiver gives the public key to the sender. The sender uses that public key to encrypt his data and then gives it back to the receiver. Now receiver knows that the data has been encrypted using the public key that the receiver gave, and the receiver uses the private key to decrypt the data which is encrypted. So the receiver has another private or secret key which only the receiver knows to encrypt the data, which ensures more security. Now, public key ciphers are also known as asymmetric cryptography. The types of asymmetric cryptography algorithm are mainly three. The first one being RSA, which is named after three scientists, Rivest, Shammer, and Altman, based on integer factorization problem. The second being digital signature algorithm, which is based on discrete logarithmic problems. The third being the elliptic curve cryptography, which is based on elliptic curve algorithms. Now, RSA and ECC are most commonly used public key algorithms, but today we are going to only look into RSA algorithm. Now, this is the flowchart of a basic RSA algorithm. Initially, you consider or you input two prime numbers. You check whether they're prime or not. If not, then you go back to the previous step and you make sure that the numbers are two prime numbers. And then when they are two prime numbers, then you tabulate two different values. First one being n, which is nothing but a product of the two prime numbers p and q. Next, t, which is nothing but p minus 1 into q minus 1. Now, the third step would be to input any number which is in between 1 and t and is even a coprime. So the condition is it has to be between 1 and t and it acts like a coprime of the value t. So you have to keep continuing this step until you find a number which is a coprime and the number is e. So that is nothing but the encryption key. Now, so that is acting as your public key, which is going to be used for encryption. Now calculating the private key D. As we know, initially the sender uses the receiver gives the sender a public key, which is nothing but E here, and then the receiver has his own private key to decode the information. So the private key, when given to the plain text and using the encryption key, gives you ciphertext. And ciphertext, when using the private key and decrypting the data back to give you plain text. So this is the basic functionality of an RSA algorithm. Now to understand it, let's look at an example. So as I said, the first step would be to select two prime numbers. In our case, the two prime numbers are 17 and 11, P and Q. Now you calculate the product, P into Q. So this is 187. Phi of n is nothing but T, which was shown in the flowchart here. So that is calculated as P minus 1 into Q minus 1, in our case 160. Now you select E such that the GCD of E comma 160, which is nothing but phi, is equal to 1, which will make it the coprime of phi. So we pick an E and then you find the private key D such that E into mod of minus 1 to the power of minus 1 of phi gives you D. So DE is equal to 1 into mod of 160. That is your phi. In our case, after using the condition, the tabulation gave D is 23. Now, how do you calculate the public key and the private key? The ciphertext is given as plain text to the power of encryption key, which is E, here in our case 7, into mod n. This is what is going to give your ciphertext. For plain text, you will have ciphertext to the power of decryption key or the private key into mod n. So this is basically a simple example of an RSA algorithm that we use for public key ciphers. Moving on to comparison between symmetric key ciphers and asymmetric key ciphers. The first one being the secret key cryptography and the other one is the public key cryptography. Then encryption and decryption uses the same key and encryption and decryption uses different keys. Used to encrypt the message content and used in digital certification and key management for asymmetric key ciphers. Now the examples of symmetric key ciphers are DES and 3DES and AES as seen before, and the example of asymmetric key ciphers is RSA, DSA and ECC. Moving on to the advantages of cryptography. It hides your message to ensure privacy of the user, and the only person who has the key would be able to read the message. So in short, it basically gives you a secure data or way of transferring a secure data. There are a few drawbacks to cryptography. The first being that the encoding and decoding of the information is very time consuming as we use complex mathematical descriptions. So you saw the longer algorithms, which is very time consuming when you have to code them. In the end, I'd just like to review a few things that we went through in the slide today. So we discussed the importance of cryptography in embedded systems, the classification of cryptography as symmetric key ciphers and public key ciphers, then the main functions of these algorithms, which is usually to encrypt data, usually at high speed levels, to provide secure communications. We studied how RSA algorithm and DES algorithm work in real-time embedded systems. And lastly, the cryptographic algorithms are used to increase security, providing high-speed communication with low power consumption systems. These are the few references that I used to make my slide, and thank you.